Hi everyone, I'm Yuki and today we're going through this math problem together. Asking us how many 5-digit numbers exist where the digits are not increasing from left to right. Let's see the examples below. Only the first two satisfy this rule. Can you see why? Since from 8 to 7, like talking about the first number, from 8 to 7, these two digits are decreasing. And from 7 to 7, the digits are the same. And they are both non-increasing relationship, right? But for the last two numbers, already from 7 to 8, it's increasing. And from 8 to 9, it's also increasing. So it's invalid. And for 3, 3, 4 to 9, 3 to 4 is already increasing, and we don't want that. But here comes a problem. How can we find all the 5-digit number that satisfy this rule? And let's break it down step by step. Let's take another look at the number of 3, 3, 4, 2, 9. I know it's invalid, but can you think of a way such that you can rearrange these digits to a new 5-digit number so that it satisfies our rule? I think the answer is obvious. It should be 9, 4, 3, 3, 2. But can you think of another way? I guess your answer should be no, because that's the case. And we can see that from a number line. We have 2, 3, 3, 4, 9. And in order to have a non-increasing digit from left to right, we must rearrange them from the largest to the smallest, which is going from the rightmost of a number line to the leftmost. So this always gives us 9, 4, 3, 3, 2. Also, the repetition of the 3 doesn't count because no matter how we switch their position, it's still the same 5-digit number and we only count it once. What does this mean? It means for any unique set of 5 digits we pick, there's only one pattern that we can rearrange it from the largest to the smallest so that it satisfies our rule given by the problem. Here we can restate our problem into a permutation and combination counting principle type of problem where we need to pick numbers, pick digits. How many ways can we pick 5 digits allowing repetitions? Like we can have 5 3s, it's still valid, but we need to pick 5 digits from the number set from 0 to 9 to count. How many ways can we pick? I will introduce you a trick called stars and bars, which is really useful in this type of question. Now step away from our 5-digit number problem. Let's play a game. Imagine we have 3 identical candies and we need to split the candies. We want to share it among 4 kids, A, B, C, and D. How many ways can we do the split? And in our game, it's okay for some students to get no candy at all. And one of these cases are denoted in the following picture, where we use 3 candy symbols and 3 bars. What does it mean? I first give 2 candies to the student A. Then I use a bar to represent that, okay, now I don't give student A any more candy and I want to switch to student B. So a bar means switching of students. Here comes our first case. And looking at the below chart, we now have 2 types of symbols. We have stars and bars. And there's total of 6 of them. 3 stars denoting that we have 3 candies in total. And 3 bars denoting that we have switched among the students for 3 times. Then how many times, like how many ways can we rearrange these symbols? It represents the ways that we can share the candies. Using counting principles, it should be 63 ways, which equals to 20. What we are counting is the ways that we can choose among the 6 symbols for 3 of them to be bars. And just in case if any of you are not familiar with the notation of C, NCR means you are choosing R objects from N objects, like the ways that you can do this choosing process. And how to calculate it is N factorial over R factorial times N minus R factorial. And for this one, it gives us 20 ways to do the choosing. Okay, now we have learned the stars and bars trick, let's get back to our 5-digit problem. We can use this table to help us. You see these straight lines? It's like our bars. Now we want to pick 5 digits, right? Give an example of, let's use 94332 again. It's a number that satisfies our rule, and we can denote this number in our table using stars and bars. For example, 9 appear once, so we give 1 star under the slot of 9, and 4 appears 1, 3 appears 2, and 2 appears 1 time. So in total, we have 5 stars. 1 star means we pick this number as 1 digit for 1 time. If the slot, for example for 0, we have no stars under it, it means in our 5-digit number there's no 0. And how many ways can we place the stars in different positions? Using the idea that we introduced in stars and bars, we have in total 5 stars and 9 bars. So there's 14 symbols altogether. And we need to choose 9 of them to be the bars to split the digits, which yield a notation of 14 choose 9, giving us 22002. Is it really that we have 2002 ways that we can pick the 5 digits to form a 5-digit number that strictly follow the rules of non-increasing from left to right? Remember, what does it mean for a 5-digit number? 1, 2, 3, 4, 5. And you can choose any set of number for the 4 digits after the first digit from 0 to 9. It will be okay because you can have 10000. But the thing is, for the first digit, you can only choose from 1 to 9. Because if you start with 0, it won't be a 5-digit number, right? Because 0 doesn't hold a place for the digit. So we want to exclude a case or exclude some cases from our numbers for our ways of 2002, right? Because there's one way that we include in our formula 14C9, which is choosing 5 zeros or putting 5 stars, putting all the 5 stars into the slot of 0. And this gives us 00000, which we don't want, and it doesn't follow our rule that the question asks. So the final answer should be after excluding this unwanted case, which gives us 2002 minus 1 equals 2001 5-digit numbers that follows our rule. So the answer is 2001. This is a great reminder of whenever we finish a question, we need to check if we have included any unwanted cases in our answer.